This is the math department website, math.siu.edu. Okay, you got to have the www in front of it. Okay, so www.math.siu.edu. Then, from there, use the navigation bar on the left side of your screen and go to course information. And you've got this whole list of stuff. You can find our department schedules for the fall semester. We have a spring semester listed. Okay, if you're considering taking more math, you feel ambitious, you can see what courses will be offered. Course syllabi. Okay, if you ever lose the syllabus or you're not sure what's going on, it is university policy that all departments have to list their syllabi on the department page. So you can always check here if you lose that paper copy. Course preparation, pretty self-explanatory, but the key thing we're looking at here is final exam preparation. And Math 101, first one listed right here. You have 3 final exams, one of them with an answer key, so you can start working through those, right? Spring 2013, fall 2012, A and B. Right, so you've got 3 finals you can start looking at. These are going to be the best way to study for the test. The way we set up the final exams, it's always the same format. Always and forever. Same types of questions, maybe worded a little bit differently, and definitely with different numbers. Okay? So if you can work these finals, you're good to go for the real deal. On December 10th, from 10:10 to 12:10 in the SIU arena. I'll say that one more time. The final exam,
SIU,
Tuesday, December 10th, in the arena, 10:10 to 12:10. I strongly recommend that you get there no later than 9:50, because keep in mind there are quite a few sections of Math 101. I teach sections 1 through 6 and 31 through 37. So that tells you how many people are probably going to be there. We have up to 37 sections with 40 people per section. I don't think you want to be fighting for a good seat. Okay. There will also be assigned seating. Your TAs have, you'll be sitting according to your TAs for your labs. Okay. They will tell you what section you should be in and what rows, so on and so forth. The issue with the arena, I apologize for this now, but there's no way around it, is there are no desks. So you will be given a lapboard, and you will be writing on the lapboard. Sorry, it's not the most comfortable setup, but it is the best way to get everyone in there, and so we can all take tests at the same time. So, if you're just coming in, one more time, the final exam is scheduled for Tuesday, December 10th, 10:10 to 12:10, just to be safe. You're putting this on your calendar or on your schedule. Say it starts at 10, all right? So that way you have time to get a good seat, get settled, figure your life out, do the test, so on and so forth, okay? You should be getting reminder emails, okay, here in a couple days, if you haven't already, from your TA. And again, you will be sitting according to who your TA is, right? So it'll be according to your lab section, all right? And of course, make sure you know, number 1, your section. You got it on your section. If it's the wrong section with like 2,000 people, we can't find you. It's going to take way too long for us to get those grades studied. So know your section, okay? And know your dog tag. You got to have at least those 2 pieces of information to get a grade on the final. Otherwise, we have to give you a grade of 0. We got too much work to do. We got too many finals to grade. Right? Question. I don't know. It varies. It depends on how they write it this year. I don't see the final, by the way. I have nothing to do with it, so I can't answer any questions about it. Question.
Randy, you mean basketball?
Yes. Yep. Yep. That's exactly what we're looking. Other questions before we get moving? All right. So, game plan for this week. Remember, we're a little bit crunched for time. Last Friday, we covered voting methods. That was lecture 16. So today, I would like to get through all of 17 and at least start lecture 18. Now, here's the thing about this stuff. It is very, very calculator heavy. Okay? If you do not have this calculator, that's okay. That's okay. But you will have to write down a lot of numbers if you do not have this calculator. Okay? The thing about this one is it actually displays all of the operations before you push enter and calculate it. Okay? If you have like that model, wave it around, the blue one, if you have that one, okay, it does almost all of the same stuff that this one does. Now the blue one, right? Put it in the case right now. You should be good to go. That should be fine. Okay, all right. Here we go, lecture 17, simple interest and compound interest. The nice thing, I think, about these last three sections that we covered is it actually applies to real life. At some point, I would like to think that everyone in here will have a bank account or will make some kind of investment or may have to take out a loan or will have to buy a car or something like that. So this is the math behind all of that stuff. Okay. Let's start with some basics. Okay. Percent. We've been working with percent. We're just going to get a little bit more into detail about it. It's just a result of expressing numbers as part of a whole 100%. Right? 50% is half of 100%, so on and so forth. And the word percent actually translates to per 100. Right? It's this much per every 100. Couple things. I'm sure some of us probably already know this, but a little review won't hurt. To express a fraction as a percent, you take your calculator and you add the numerator by the denominator, which means you take the top number divided by the bottom number. Those are your keystrokes. Top number divided by bottom. And then you get this decimal. Then you have to multiply that value by 100. Now the other way you can think of this is moving the decimal point 2 places to the right, tack on a new set sign. So let's put it in practice. Express 5/8 as a percent. So here's what we write down first. On your calculator, you actually type in 5 divided by 8. Now, my darlings, if you're chatting about the notes and all the stuff, that's fine. Probably I can hear you all the way up here. So take it down, please. When you do divide over 8, you get the decimal 0.625. To express this as a percent, you can move your decimal point 2 places to the right. So that gives you a grand total of 62.5%. Yes? Okay. Like I said, stuff that we've probably seen before, but sometimes the basics are always good to review. Now, you also have to be able to convert from decimal to percent. Go backwards from percent to decimal. All right. For example, 1 part A. To convert to a percent, that's what we just did. You take your decimal and you move it 2 places to the right. So decimal to percent, move it 2 places to the right. So this one is 102.3%. Okay. Part B, same idea. 2 places to the right. So look at that. We still got the 8 after the decimal. This is just my personal preference. I always say 0.8% instead of just 0.8, because sometimes if you don't write the 0, you don't see the decimal. So I always put the 0 point as a number. Okay? Let's use a little intuition here. If you go 2 places to the right for decimal to percent, you want to go the other way, percent to decimal, you move it 2 places to the left. Okay? So convert to a decimal. 23.4%. Take a decimal point, and we just said to go the other direction, 2 places to the left. That is 0.0. actual amount that it has increased, you take the amount of increase divided by the original amount. And then, remember, you have to end up back as a percentage, so you move the decimal 2 places over. So, let's look at this example. If we have a jacket, regularly sells for $135, and it's on sale for $60.75, find the percent the jacket is marked down. So percent increase, percent decrease, it works the same way. You just got to know what kind of numbers you should end up with, right? Let's start by, first of all, finding the difference in the prices. So if it was originally $135, and the new price is $60.75. Let's subtract those. All right, let's punch that in your calculator. 135 minus 60.75. That means there's a difference in price of $74.45. But that's not what the question is asking for. We want the percent that it has been marked down. So we have the dollar amount it was marked down. We need to know what percent of the original that amount is. So we take step 2, our 74.25 out of the original price. So divide that by 135. And that gives you the decimal 0.55. But again, remember what it's asking for. It doesn't want a decimal, it wants the percent. So your third step here, move that decimal 2 places to the right. You want a percent. This was marked down by 55%. How are we doing? See a lot of pencils moving, so I'll give you a second to catch up. Okay? So everybody loves a sale. Everyone loves getting a discount. Oh, sorry, questions?
I was on the original spring. On step number 3.
Yep.
Go back to step 3.
All I did, since the question is ultimately asking for a percent, step 2 only gave you decimal. So you got to convert it. So we took that decimal point right there, moved it 2 spots over, and that gave us step 3. We good?
So that was the percentage decrease?
Yes. Yeah. You got a 55% discount on that original $135 jacket. What are you pointing at? Other questions? You gotta wait frantically. What you got?
Sorry, we're going to take 135 and divide it just by the 60.75 because the opposite thing would be greater than 2.
You have to subtract the 60.75. You need to know how much, okay, keyword here is the difference. You need to know the difference of the 2 prices. If you say the word difference, that means you have to subtract. And then whatever that difference is, you want to know what percentage of the original. That's why you divide the difference by the original value in percent. I think that's what you were asking. It has to be this order. Otherwise, it will be incorrect. Is anyone else waving frantically at me? Okay. So back to our discount. Everyone's had to go shopping at some point. I know some of us probably don't enjoy it, but we definitely enjoy getting a good deal. Okay. How do you actually calculate a discount? Well, it's the percent of the original price. And here's your formula. The discount amount is the discount rate written as a decimal times the original price. Okay, so here's the key thing. Your discount rate has to be written as a decimal. Then you multiply that times the original price of whatever it is you buy. So that's step 1. The second step, to find the actual sale price, you have to take your original minus the discount from from step 1. Okay. Let's do an example. Right. Percent of sale price. We want to buy a computer. Our current computer just crashed and burned. We got the blue screen of death. So you got to go get a new laptop. All right. The original price was $14.60, and it's on sale at 15% off. Okay. Two things we got to answer: what is the discount, and what is the computer's sale price? So remember, to find the discount, you start by multiplying your discount rate as a decimal times the original. So our discount rate was 15%. That's the same as 0.15. Okay? So we take our 0.15 times the original price, $14.60. Punch that in your handy-dandy calculator. And that gives us $219. Okay? So that is your discount amount. That's how much you get to take off the price. So the final sale price of the computer, your step 2 from the previous slide, take your original, $14.60, minus the discount amount of $219, and dandy calculator. I've got 1,241. Okay. Like I said, it's going to be pretty calculator heavy, pretty mathy for these last couple sections. How are we doing? Yeah? All right. So there's our discounts. Next up, simple interest. Okay. When you make an investment, you do so with the hopes that your investment will make enough interest that your money will actually grow, right? The higher the interest rate, faster your money's going to grow. That's a good thing. Okay, well, how are we going to calculate this? There's 2 types of interest we're going to talk about. There's simple interest and compound interest. Starting with simple interest, there's a few things we need to know. Interest itself is the dollar amount that you get paid for lending money, or the amount you have to pay for borrowing money. Consider a credit card. If you have a credit card, essentially you are borrowing money from one company, right? And of course they'll give you that deal of, 12-month interest-free financing. But then watch what happens if you don't pay it off in 12 months. They smack all of that interest that you would have earned onto the bill, right? That's why if you pay off part of your credit card and you have like $50 left, you're thinking, next month I just have to pay $50. No. There's still interest that's calculated on it. You might end up having to pay like $55 next month because of that interest rate, okay? You're accumulating interest there. Now, starting out, before you ever deposit anything or before you ever borrow money, you have an initial amount. That's your principal. Okay? Principal is always what you start with, what you initially put in, okay? The amount of credit that you initially have. Now, the amount of interest depends on the principal itself, right? That's the idea. The more money you put into investment, the more interest it will make, right? And we have the interest rate. Typically, it's listed as a percent, and it will vary from bank to bank, and of course, the length of time that you keep the money deposited. And then the first version that we're going to talk about, simple interest, this focuses only on the original principal. It does not take into account how much money is in your bank account or in your investment at the end of the year, and then use that. It's always just the original. Here's the formula. To calculate simple interest, times time. Okay. Now that's just for the interest itself. The rate, R, is always a decimal. T stands for the amount of time for your investment, and unless told otherwise, it will be always given in years. Okay? Now watch for that. So R is a decimal. T has to be an amount of time in years. Let's apply this. We're going to put $2,000 in a savings account at Hometown Bank, bank of your choice, with a rate of 6%. First thing we need to do, find the interest at the end of the first year. Okay? Use the formula. I equals P R T. So I is our interest, how much we have at the end of the year. So we're just going to plug in. Our principal P, how much did we start with? 2,000, $2,000. What's our interest rate? Be careful, it's 6%, but if you type that in your calculator, you have to type it in as
0.06.
0.06. And how much time has passed? Remember, we're talking about years. 1 year, so multiply by 1. Is this clear where these values are coming from? Wait for answer, please, it's not. Okay. And put that in your handy dandy calculator. 2,000 times 0.06 times 1. I have I equals $120. Okay. So that is how much interest you're making on your initial deposit. Now you have to find out how much money you actually have at the end of the year. Okay? So you take how much you started with. You started with $2,000. You had $120 in interest. So $2,120 after 1 year. Still with me? Okay. Questions on simple interest? So there's essentially two calculations that go on here. First, you have to be able to find how much interest you're actually making, right? That was part A. Part 2, you have to know, or you have to be able to find how much money you have at the end of your year, after you've already added the interest to your account. Next step, future value. We're taking the same idea of interest, right, simple interest, and we're adding to it something else. So if you look at formula, the future or accumulated value is given like this. PRT, remember that was how you calculate the interest. And then you add to it your original. A is your final amount, or accumulated value. That's why we use the letter A. Another way you can see this formula is over here on the right. P times the quantity of 1 plus RT. They mean the same thing, they're just a little bit different. Let's apply this. Example 6. Calculate the future value for a loan of $1,060. It has 6.5% simple interest for 3 months. Okay. Couple things you need to watch out for. We said 3 months, but remember time is always given in years. All right. So let's see how this is going to lay out here. Using our formula, A is equal to P plus PRT. Right? Same formula. What was our principal amount? 1060. Plus. Still have the 1060. Our interest rate, yes, it's 6.5%, but how do you type that in your calculator? You gotta say it loud. 0.065. Now for our time, since it has to be in years, but we're only given a unit in months, you can type that in as 3 months out of 12. Put a star next to that. 3 out of 12 months. Okay? So these are the actual keystrokes you would use to type it in your calculator. You start 1060 plus 1060 times parentheses. You should have parentheses buttons on your calculator. 0.065 times parentheses. That's 3 divided by 12. Close it off. So 1060 plus 1060 times parentheses 0.065 close parentheses times another set of parentheses 3 divided by 12 close that set of parentheses. I've got 1077.23. So if we initially deposit $1,060 at 6.5% simple interest, after 3 months, you should now have $1,077.23 in your account. So that is the future value. Possible exam question? Give you a second to write that down. We are depositing $2,000 initially at 7% simple interest. Keyword there, simple interest. What is the balance after 2 years? So we want the future value for that investment after 2 years.
What was the answer on the last?
On the previous one was 1077.23. Question?
Previous question, how did you work the 3 over 12? What did they put?
In that last set of parentheses, so you would, the button you push on your calculator, parentheses, 3 divided by 12, close parentheses. Okay. Do I see a hand waving in the back? Maybe? Okay, anybody still writing? Okay. We have to be able to work backwards as well for this type of problem. Okay? If you can calculate your future value or find your interest, the amount of interest, you must also be able to find your interest rate. Okay. I'm going to get a little bit algebra heavy, so hang with me. We'll take this nice and slow. We borrowed $2,500 from a friend, and we promised to pay them back $26.55 in 6 months. We need to find out interest this friend is actually making off of us. So, if we're finding the interest, that means according to this formula, we are solving for, look for the formula. What letter are we trying to find?
R.
R. Solve for R. We're asking for what simple interest rate. Here we go. Start by plugging in the numbers you already have. Okay? So our initial amount, or our final amount, excuse me, A is your accumulated value. You're going to end up paying $26.55. So that's our value of A. Is equal to the principal amount that we borrowed. Principal amount was $2,500 plus $2,500 again. Remember, we're trying to find R, so we'll leave him there. And time is expressed in years, but we're only given 6 months. Well, 6 months is 0.5, half a year. Okay? Keep your eye on the prize. Remember, we're trying to find R. So let's put all of the numbers together that we can. Leave the 2655 and leave this first 2500. Now we can do this part. Multiply the 2500 and the 0.5. You can do that on your calculator. And you should get 1250. But don't forget that it's 1250 with that R still attached. The R hasn't disappeared. It should still be there. Okay. From here, subtract the 2500 from both sides. Okay, so that's gone. This leaves us with, let's see, 2655 minus 2500. 155 on the left is equal to 1250 times R on the right. Okay. Final step. Remember, we're trying to get R by itself. That's what we're solving for. Divide both sides by 1250. So you punch in 155 divided by 1250 into your calculator. And you should get the decimal 0.124. That's the decimal. Single interest is a percentage. So convert this decimal to a percent. Move your decimal place over 2 spots. So the interest rate is 12.4%. Man, your friends think will bank off of your money they bought from you. Please. Okay? Questions? I very, very strongly recommend that you rework these problems on your own. Okay? Follow these processes. You need to get used to writing down these steps just like this. The calculator is there to help you and kind of speed things along, but it must be written this way. Okay. So we talked about simple interest. Remember, simple interest only focuses on the principal amount, right? The next thing we have to talk about is when we start compounding your interest. All right. If you compound an investment annually, that means interest is paid on both the principal and the accumulated interest. It's like you're reinvesting your money each year. Okay? And you get to have interest on that new amount that you invest. So that's the difference here. We're going to start with $1,000. We're going to deposit it at 10% interest compounded annually. So compounded annually, you only compound it once a year, right? That's how many times you're going to keep reinvesting. Let's see what happens after 1 year. All this mathy stuff right here comes directly from the formula we were just using. A is equal to P plus TRT. And you can see that in all the numbers, okay? Now here's the thing. At the end of 1 year, plug into the formula, you get $1,100. Since we are compounding annually, that means we're going to take that $1,100 from the first year, you're going to reinvest it at the beginning of the second year. That's where it comes from right here. Do the same formula, except you're using $1,100 now. And then at the end of the second year, you now have that amount. So you're going to reinvest that. So we're going to compound that interest again. That's your principal amount for your third year. And you end up with $1,331 at the end of 3 years. Okay. Questions? So this is one way to do compound interest, but say if you're investing over 20 years, you don't want to do this calculation 20 times. Okay? If you're only doing 2 3 years, sure, this is fine. It's a little easier to see the math of what's going on. But if we're doing this on a grander scale, say like a Roth IRA, 401k, saving for retirement, you want to know how much money you got at the end of, say, 30 years of work? There's a formula for that. Question?
For the second and the third year, do you have to use the 1100?
Yes, because remember we are reinvesting. Key thing there. When you compound your interest, you reinvest what you have at the end of that last year. That becomes your new principal for the next year. You do the same formula, and you earned some interest. You made more money that year. So you want to take that new amount and you're going to reinvest it one more time for that third year. Make some interest, do the formula, and then you get your new amount. Okay. So when we're compensating,
Would it be the same if you use the principal and just change the year?
no, try it 3 times. Doesn't work. You got to do the calculations 3 times with that new amount each time. Okay. Good? All right. Simple interest. But now, we're going to get a little more intense here. Compound interest. This is an example of what we call exponential growth. Hey, we like it if our money grows faster, right? Always go for an account that has compound interest. Here is our formula. So A still stands for the accumulated amount, so that's what we have at the end of your investment. P is your principal, is what you start off with. 1 plus R over N raised to the NT power. And then down here you have your legend for what each of these variables stand for. R, rate of interest, that will never change for these formulas. Remember, it must be written as a decimal when you punch that into your calculator. N is the number of compound periods per year. Some accounts compound quarterly, so 4 times a year. Semi-annually, twice a year, or biannually, depends on how they use terminology. And then annually, once a year. Okay. On the next page, time, still years. Remember, unless told otherwise, always years. Here are your compound periods. So if you see any of these keywords on the left side, these values tell you what to plug in for N. Okay. So learn that chart. You will need to know that for the test. Okay. Man, interest compounded daily. You make so much money. That's awesome. All right, let's apply this. Example 9. So we're going to use the same values, but we're going to deposit them for a longer amount of time. So if we're doing annual compounding, that's the same as compounding once a year. Okay. For quarterly compounding, you are going to be doing this 4 times a year. Right? So let's start with part A. And we're using that new formula. A is equal to your principal amount times 1 plus the rate over the number of times compounded. All of that quantity is raised to the N times T. So number of times compounded times the amount of time. Here we go. First, let's start by writing all of this out, and then we'll go through step by step how you do this with the calculator. So for annual compounding, plugging into the formula first. A is equal to your principal amount of 1,000 times 1 plus. What's your interest rate? Say 11? 0.1. 10%. 0.1 over. If we're compounding annually, our value of N should be 1. All of that raised to the exponent of 1 times how many years? How much time are we going to keep this investment in there? So 1 times 10. All right. Now some of this you can start doing by hand first. Start up here with the exponent. So let's do a rewrite. So A is equal to 1,000 times 1 plus, well, 0.1 divided by 1 is just parentheses. So A is equal to 1,000 times 1 plus 0.1 would be 1.1 to the 10th power. The next piece you want to do, now that you only have one number in that parentheses, you have to apply the exponent. So on your calculator, if you have this one, the gray and white, you can type in 1.1, and then over here on this side, this button right here, the little caret, at the top of an arrow, you push that button, and that will let you enter in an exponent. So we can enter in a 10. Okay. So I now have A is equal to 1,000 times, I got 59374. Okay. So we take that number now, and we multiply it by 1,000. So my final amount, $2,593.74. Okay. Very nappy. Lots of calculations. How are we doing? So quarterly compounding works the same way. I'll do this one in green so we can differentiate between the two problems. Start by plugging into the formula. So our final amount, A, is equal to our principal of 1,000 times 1 plus. The interest rate is 0.1. How many times are we compounding? So over 4. And then our exponent, this gets raised to the n times t. So we're compounding 4 times, that's n. And over 10 years, so 4 times 10. Still with me? All I'm doing is writing this down. Here we go. Let's rewrite. We can do some of this by hand, so let's do this part up here. Simplify that exponent. And we can go ahead and simplify that part right there. So we're going to do these in 2 pieces, but we've got to keep writing it down. So A is equal to 1,000 times 1 plus, on your handy-dandy calculator, 0.1 divided by 4. I got 0.025, and then that exponent becomes 4 times 10, so 40. Yeah? Next thing, put this stuff together in the parentheses. A is equal to 1,000 times 1.025. You still got that 40 hanging out on the outside. And now we use that caret button on the calculator to do this part right here. So A is equal to 1,000 times. Take your 1.025, caret, so exponent, raise that 1.025 to the 40th power. And I've got 2.68506. Then you multiply those 2 numbers together. Gives us a grand total of, let's see, 2685.06. Okay. Now I know we still have 4.5 minutes left. Don't fidget, because we will actually be able to get through the rest of this section. Hang with me. Questions on compound interest? Okay, we're almost done. Now we are found the, what we call the future value, right? Now we're going to give you the future value. We need to find out how much you initially invested. Example 10, here we go. We need to end up with $15,000 to pay for college whenever your kid is 18 years old. Okay? We buy a CD, certificate of deposit, and it has an interest rate of 10% compounded quarterly, guaranteed for the amount of time, that period of 18 years. How much do we need to deposit initially? Okay? So, same formula, but now instead of solving for that final amount, we know how much we need to end up with. For this one, we need to solve for P, solve for the principal. Let's start by plugging in. All right. We want to end up with 15,000, so that is our accumulated amount, that's A, is equal to, well, we don't know our principal yet, so we'll leave that as P, times 1 plus, our interest rate is 0.1 over 4, we're compounding quarterly, all raised to the 4 times 18 years. And we follow the same process. So keep the 15,000 equals P times 1 plus, okay, with the calculator, 0.1 divided by 4 is 0.025. 4 times 18 gives us 72. Okay. Put that stuff together in parentheses, so 15,000 is equal to P times 1.025 to the 72. And now we put together those values. So that becomes P times, on your calculator, 1.025 raised to the exponent of 72 gives us 5.91723. Let's round that off. In order to get P by itself, you must divide that 15,000 by that 5 point yada yada yada. Which gives us let's see, I've got $2,534 and let's say 97 cents. That should be your initial deposit amount. Okay? Let's see. We only have one more example left, so we'll go ahead and leave